I'm just going to record on my own computer, and then it's to analyze the conversation. And then you will be able to say also in the sheet if you would like to be named as a company or whether you would be like an anonymous interviewee for the research. But you can decide it also afterwards. But I think you will probably want to be named.
Yeah, named as a company also, of course.
Yeah.
So yeah, I'm fine with the recording. So earlier on you mentioned like this the scalability, and you know I've been in this thing since 2007. In 2007 we started the Green Roof Company, and you know of course high hopes that this was going to be a fantastic solution for stormwater management. I was at one point a board member for Green Roofs for Healthy Cities. So I was actually very active on, let's say, on a policy level, try to get green roofs to accelerate. Because
was it already in the US or was this in the Netherlands or elsewhere?
In the US. I've been here for the last 30 years.
Okay, yeah.
So I didn't have any gray hair when I came here, and now it's all gray. I used to look like Evo. So.
That's why you hired him now, just kidding.
So I ended up being really frustrated with let's say our industry and then also with green roofs as a category, because I find it very difficult that let's say in Europe and in the US they have difficulty quantifying the value of a green roof. So in Europe it is going 100 miles an hour. The German market is 80 million square feet, roughly 8 million meters a year. That is about 10 times as large as the US. And that's just Germany, right? So that's a lot smaller. They have smaller properties, they have a smaller population, and they do 80 million versus 10 million. And so then you go to Germany and you ask people in Holland and Belgium and England, what exactly are they trying to achieve with a green roof? And they don't quantify it. So, well, when you ask a specific question like how much are you trying to hold per square foot, or how much are you trying to detain, or what are your metrics? What are your goals? Their metric is basically the color green, and most often as a result, it's of let's say of policy-based green roofs. You see that they are not so green after 3, 4, 5 years anymore, because the only incentive in the marketplace is not to intellectualize or to raise the game. It is to actually, lower the game by seeing who can be the lowest bidder. So when you don't have solid metrics, you see that price becomes the overriding factor, and it's just a matter of getting 5 quotes, and then the lowest bidder tends to get the project. And so what you see very clearly in Germany is that it's a very undesirable market. It doesn't really produce a great quality green roof. It doesn't achieve any of its stormwater goals, quite frankly, if you really understand stormwater and how it interacts with a green roof. And, a lot of these roofs, people just try to minimize the, if a green roof is mandatory, like it is in Munich, for instance, then I think it's a much better way to look at it is to look at it as a tax. You got to pay taxes. And nobody likes to pay taxes, so they try to avoid all kinds of ways to pay taxes. And a green roof that is mandatory is also one of those things. You incentivize the buyer to go for the lowest bidder, and it's really unusual because you buy this as a tool, as a stormwater tool, yet there are no metrics and there are no clear incentives or ways of encouraging somebody to do go a little bit above and beyond.
Yeah.
Then you go to the U.S. In the U.S., been here for 30 years, as I mentioned. I really like this culture and its business environment and everything else. By and large, they don't really give a damn about the environment. The house that I live in, the car that I drive, it all kind of contradicts, let's say, a very sustainable way of living. But Americans, once you give them a dollar and cents proposal, they tend to be very sensitive to their argument, and $1 million decisions are being decided in a matter of 5 minutes or less. So, I've been looking for let's say, an ROI argument, and And that was born out of my experience here in the U.S. So here in the U.S. you have markets like Chicago where you get a green. Somebody decides to invest in a green roof in Chicago because they have a fast track program. That means that you're going to get your permit within 6 months instead of 3 years. So it's almost like you're being bullied into getting a green roof. In Portland, they had a huge rebate, which now disappeared and it really kind of collapsed the green roof business over there. In Toronto, they have a bylaw that says if your roof is larger than 2,000 meters, you have no choice. You're going to have to do a green roof. And for instance, in Toronto, you see that the number 1 and number 2 green roof supplier are the 2 worst stormwater systems, but they're very competitive. They're just cheap. In Chicago, there is a slightly higher quality just because of the marketplace. The players that are out there, they tend to be a little bit more of a higher quality, higher caliber. In Philadelphia, they just say, 3 inches of soil. And it doesn't really matter if that 3 inches of soil is made out of ping pong balls or if it's made out of really good quality retentive soil, Okay. So, in New York, they have a phenomenal rebate now of $300 a square meter, which is phenomenal, right? Green roofs are very expensive in the U.S., so $300 a square meter, in New York City, probably you can break even. In most markets, it's fairly expensive.
So for New York, that's a cheap green roof.
Pardon?
So for New York, you're saying that's quite a cheap green roof.
Yeah, because logistics, road closures, craning, just toll, parking, labor.
Yeah. And on a side, on a side note, Helen, this is just an extensive green roof, what Oscar is talking about, right?
Yeah.
This is just your typical 4-inch thin profile green roof.
Yeah.
So then you look at Washington D.C. and Washington D.C. was the first city that actually did an attempt to quantify the performance of a green roof. And now New York is also following. In Washington D.C. they said we have 2 districts. We have 1 district that has combined sewer, and we have 1 MS4. MS4 is basically that has separated sewers, and you're allowed to discharge your street water or your surface water into the rivers, but it needs to go through some kind of a rain garden, something that kind of cleanses that water a little bit. In the combined sewer, of course, your sewage and the street water is combined in 1 pipe, and there you need to retain 1.7 inches. So 1.7 inches in the CSO and 1.2 inches in the MS4 district.
So the CSO is the combined sewer.
Yeah. So that's the first market where they actually have kind of quantified a performance. And that is wonderful because all of a sudden you got to use a calculator and your brain in order to do something because gathering or retaining 1.7 inches in a 4-inch profile is actually kind of difficult. So then 4 years ago,
just to make sure I understand it correctly, so they quantified what they wanted from a green roof to be successful. So what is this 1.7 inch? Just to make sure I understand it.
So and this is a theoretical. So the laboratory testing that you do needs to prove that your sandwich, your stack of layers, can go from a dry to a wet stage and then basically absorb 1.7 inches of water.
Yeah, in a 4-inch layer.
In whatever layer, actually, quite frankly.
In whatever layer, yeah. Okay.
Yeah, so if an 8-inch roof or a 4-inch. So of course, most people want to do it in the 4-inch roof because it's lighter, cheaper, less materials to haul and everything else. So therefore, and 4 inches is kind of the minimal that you need here for plants to survive. It's a lot. We're like 20, 25 hours south of you. We're more like, southern Spain and Portugal. So it's a lot more difficult on the vegetation over here.
Yeah.
So that actually kind of made it fun. So we built a laboratory and we said these laboratory tests that everybody does, that they take the drainage layer is one test, and it goes to company laboratory A, and the mineral wool goes to laboratory B, and then soil goes to laboratory C, and then they tally up A, B, and C, and let's say if the test result was 1 liter for each layer, they say, oh, you know what, this is a 3-liter system. So, and then in the soil, they actually simplify it. They say, well, if 10 centimeters holds a liter, then 20 centimeters of soil holds 2 liters, and a meter of soil holds, 10 times as much.
Yeah.
So there's a diminishing return in soil. The higher the soil column is, the less water it holds. So we were frustrated with all of these simplifications, and we said, you know what, we're going to build a full-scale laboratory setting where we can control everything. And then we create these cassettes. They are a little more than a meter by 8 meters. So, and we can, with a crane, you put them down on a rail, they roll into the laboratory, and then we can test them. So we thought, we were like, oh, this is great. So we're going to be the only company that can actually focus on retention. And retention, by definition, is any water that is held as a sponge or in a cup, and that water can only leave the system through evaporation or transpiration. So it's an upward movement of water. So that is the definition of retention. And I bring this up rather specifically because it is very much misunderstood by our own industry. So we focused on retention. How much water can the system hold as a sponge, and then from the driest state to the wettest state. So we built a laboratory that we started with a $10,000 budget, and it became $160,000, within a year. So this is really high tech. Everything is in certified scales. Everything is computerized. That's what happens if you, I like toys, and if you have no budget, then that's what, a $10,000 project becomes $160,000. But we thought that we were on the right track. So we took these results to the first civil firm that we know of in DC that does a lot of green roofs, and they were super enthusiastic. They said, "Wow, this is great. Fantastic. This is really the kind of information that we need." And then an hour later, he puts it in a drawer, and he closes the drawer again, and he says, like, "What else you got?" And and we're saying, like, "Well, what do you mean? What else we got? We just showed you, like, we had hoped that they would take that information seriously because, we went away from the theory, we did the actual, and the actual is about 20 to 30% less than the theoretical. So we thought that they would have more faith in a higher quality test, a test of the full sandwich instead of individual layers in separate laboratories. And but nevertheless, I didn't address this problem somehow. So I didn't understand a word he was saying. So I went to the next one a week later. Had the exact same experience. I basically got rejected for my retention argument, and then it happened this third or fourth, fifth, sixth, seventh, and then eighth time. And the irony is that I didn't understand the reason why I got rejected, and that was actually the frustrating part. So it's kind of strange, right, that we are in a stormwater industry, and then the civil engineer cannot articulate somehow, why a green roof is not satisfying his concerns. And there's all kinds of contradiction with whatever you read. We've downloaded 1,700 scientific journals. We're plowing through all of those as we speak. And, there's tons of really great stuff with civil engineers that confirm the green roofs are great, blah, blah, blah. So they must be great, right? So how is it possible that you have two engineers in the room and one says they're great and the other one says, they don't do anything for me? So then I go to Chicago, Spaceco, big firm, 350 civils, and they've done 35 green roofs. So I asked them in the audience, and I got everybody in the firm there, almost 40 people. And I asked them, I was like, hey guys, which of you have done a green roof? And nobody raises their hand. And it's like, this is bizarre. You guys built 37, roofs, and nobody in this room has been part of it. How's it possible? And they said, like, well, we just happen to be on the same project. Just because there was a green roof there doesn't mean we're associated with that. It's like, well, but you're the civil on record, so why aren't you? And they said, well, quite frankly, we don't really get involved in the green roof. And well, that just makes no sense. This is a stormwater tool. You're managing stormwater. That's your job. Why aren't you taking the green roof more seriously? And they said, well, the green roof for us is solution number 14. And I said, what does that mean? And they all started laughing because they all know that solution number 14 means that's the last resort. And it's like, wow, how the hell is it possible that I'm in this industry that is apparently full of people that believe that green roofs are great, yet these civil engineers, one by one, all tell me that they're not. So finally, I meet Joshua Robinson, and Joshua Robinson is a civil engineer that can speak English just like I do. He can explain everything, using examples of hamburgers and baseballs and automobiles and stuff that let's say an average person can understand. And what you come to realize is that there's a huge gap, an enormous gap between the complexity of civil engineering and then the simplicity of the green roof industry. We have lost complete credibility in the eyes of the civil engineer. So a civil engineer, they believe the green roofs are great, and on average that they reduce volume and that they are a great benefit, but they don't consider them, if you ask the question properly. And I was in Holland a couple of months ago, and in Holland they kept on saying that, we're wrong, it's different in Europe, it's different in Europe. I said, well, set me up with a civil. I said, and within 5 minutes, I got this guy in the corner. So it sets me up with a civil, and the question is green roof good? Yeah, green roofs are great, and blah, 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 all these wonderful things. And so, well, let me rephrase the question. Is your green roof a top 3 stormwater management solution? Oh, no, absolutely not. How is it possible? You just told me that it's great. Well, yeah, it's great, but, it doesn't work every time. That's why we don't take it seriously. But, we very often use it to, fill up the last 5 or 10% of our problem. Yeah, it's bonus. And that's what every civil engineer tells me. It's like the green roof is a bonus. So then, put icing on the cake. This is the last example. 40,000 square foot project in DC has a green roof on it. So that's 4,000 meters. It's a sizable, half a soccer field. He ends up, or she actually, Esther, she's the owner of that architect firm. She calls me in one day. She's like, Oscar, I got bad news for you. She says, like, we're taking off the green roof and we're putting solar on there. So then I asked her, it's like, well, I'm really curious now. So you're replacing a 40,000 square foot sponge with a 40,000 square foot glass plate. So what did that do to your stormwater facilities? What did it do to the pipe diameters and the tank sizes and the overflow scuppers and everything else? And she said, like, nothing. We didn't have to change anything. And I said, you know what, that is a wonderful confirmation that, a typical example again of a civil engineer that puts on a green roof for regulatory purposes, but doesn't take any of the benefit of the green roof into his calculations. So the moment he replaces the sponge and replaces it with glass, or basically, take it all off, solar and green, then there is absolutely no benefit to the building owner, the investor, to put a green roof up. Now that's harsh reality, and I got some good news at the coming up soon. But it is extremely important, and I have to hammer this message in all the time. That you have 2 civils. You have a city civil, and the city civil is delighted with green roofs because they reduce the volume of that of the water that has to be cleansed by let's say 50%. So they really like green roofs, but not from a peak flow and peak flow reduction and a peak flow delay perspective. They only like it from a volume reduction perspective. And the reason why they don't think it has any peak flow reduction or peak flow delay capacity is the same reason why the building civil engineer, so that's the other guy, why he doesn't like it or she doesn't like it. And it's a very simple reason. And I just happen to have a glass of water over here, but the green roof industry basically says, you know what, this is the capacity of a green roof. And the civil says, you know what, Oscar, it's not true. It rained yesterday, it was full, and now what happens? And it's like, yeah, but you know what? On average, it's not always full. And it's like, yeah, but I don't deal with averages. I deal with worst case scenarios. I need to have a stormwater solution that works every time, you know, within 3, 6, 12, 24, 48 hours, depending on the regulations. And a green roof that is soaking wet from yesterday's storm, we call it a second day storm, you know, it doesn't work. And, you know, if you get a 6-inch rain event and you have a 4-inch profile, you know, with 2-inch storage, it also doesn't work. So that's why. So that was really a shocker, is to come to that realization. And it's not like the first 8 civil engineers failed to explain that to me. And it's such a bloody simple concept, right? But I just explained it to you in the form of a glass of water. They go into all kinds of formulas and they go to all kinds of complexity and all these exceptions and blah, 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 blah. And it's so simple. A second day storm or an XL storm, you cannot put a 2-gallon rain event in a 1-gallon bucket. So that became pardon?
Yeah, and that's, I guess, so what I understand from your story is that that's what they're most worried about. So they are building to manage the peak events, and not kind of the average, like get most cases you get less runoff water, but in some cases you still haven't solved the problem, and therefore they don't take it as a solution. Yeah,
if you look at think of it, let's say you have in DC you have about 100 storm events in a row in a year.
Yeah.
The first 50 are so small, it's kind of irrelevant. You know, asphalt would be able to deal with that, just evaporating off the surface of the asphalt. Then you have another, so let's say out of the first 50 are irrelevant. Then there's another 20 or 30 or so that are pretty sizable, but, you know, only half a centimeter or maybe a centimeter. And yes, you know, the green roof can cope with those quite nicely. And then, you know, so that now we're up to about 70. And the last, you know, well, even let's say the last 15 are your, well, let me rephrase that. Of the last 30 or so that you have left, about 20 of those are all subsequent storms. So they happen, you know, the rain on Friday and on Saturday and on Sunday. So the storm individually was not too big, but stacked on top of one another, they are too big. And then you have about 5 to 7 massive events. Just you know, all hell breaks loose and you get an enormous amount of water. So the civil doesn't give a damn about the first 70. The city doesn't give a damn about the first 70. Really, all the money and all of the promise is in the last 30. Mm. So once we realized that, we started looking at green roofs totally differently. We started adding the element of time, because retention is a static number. It's a fixed number from dry to wet, and it has a maximum ceiling, and that is. What is very confusing in the literature says, you know, I mean, I can find you tons of really good white papers, but they make one big mistake that they say that, oh, you know, this green roof is able to create, you know, 30-minute detention. Detention is any kind of time delay from the peak of the storm to the peak of the outflow. Mm-hmm. Now, if you have a glass that is half full and you start filling it up, you know, that is a time delay, but that's not really detention, because that water will never, will always stay in the system and will evaporate outwards. The true definition of detention is water that is exceeding the storage capacity of the system. And at that particular moment, it's not a matter of, you know, how much comes off, because all of it will come off because the bucket is full. But the question is when does it come off? Now, on a green roof, that is basically within 30 seconds that water has reached the drain and it's gone off. Now, in a watershed, and I don't know, is a watershed, is that a word that you're familiar with?
I maybe give some examples. Like I always think of things like swales and these type of things, but maybe I'm not. Or watershed, as in everything comes down at once.
Now, it's a kind of a so a watershed is, for instance, so we're in Virginia and we have the Blue Ridge Mountains, and all the water that falls on the, let's say, the east side of the Blue Ridge Mountains, it all sheds to one part of the U.S. and it basically all congregates. We have a beautiful map that shows all of the watersheds in the U.S. There's also a beautiful watershed map of Europe, and you can see exactly where all of that water, it's like a gigantic leaf that, of course, goes in the opposite direction. The very fine veins become thicker and thicker and thicker, and it ends up in a river somewhere. So that is called a watershed. So the EPA has, in the 90s, allocated a couple $2 billion towards writing software that can cope with watershed calculations, and I think the whole world uses their software. So they can literally calculate how long it takes for a water drop to fall at the highest point of the mountain, and how long does it take for the water drop to travel all the way down to the river. Now that calculation is affected by three things only. Well, three basic things. One of it is, of course, is the distance from the peak of the mountain to the river. The longer, the better. One is the slope. The flatter, the better. And one is friction. So if the water that basically, and so the soil is assumed to be 100% saturated, so nothing can get into the soil. Everything has to go over the soil. And basically, let's say a very dense prairie has an enormous amount of friction. A lawn has a little bit less friction. An open cornfield that has been farmed has almost no friction. So they have these values, these friction values, and they basically just tabulate that, and then that's what calculates that friction, and then the time frame. So that's basically what we're trying to replicate on a properly designed green roof. The distance to the drain is fixed. There's nothing we can do about that because it's a whole different engineer, quite frankly. That has to do with building safety and everything else, and there's no way in hell you're going to change their behavior. The slope is maybe adjustable, but that's a architectural preference and then a building comfort. So flatter is better, but a lot of times 2% slope that's just industry standard. And then the last one is friction. So the big drawback of a green roof is that it has no friction. The friction that you normally have in the foliage layer is actually eliminated because the soil underneath it has no saturation point. Because it has a drainage layer underneath, and the drainage layer underneath always allows you to vacate the extra water. So there's never any surface flow. There's always flow that goes vertically through the green roof profile, and then underneath it flies Autobahn speed to the drain. So, to compare a green roof to a natural system, it's a two-legged stool that's going to fall over. It just doesn't work. So that gave us an opportunity to say, like, hey, what if we slow down the velocity in the drainage layer? If we can prevent the water, if we can create artificial friction in the drainage layer, then we're backing up the water. And then now, as a consequence, we basically start raising the water table in the soil profile all the way up to the surface. And we create a fully saturated condition, which then allows some of that water to basically find friction through vegetation over the vegetation towards the edge of the profile. So now we have completely replicated, and we made a true, natural, very simple green system out of it that functions exactly like nature does. Now, the soil that we use as an industry is kind of ridiculous. It has a vertical flow rate of about 5 meters per day. It never rains 5 meters per day, but that is some kind of a crazy objective that actually got accidentally copied and pasted for all the wrong reasons from Germany across the whole world with that FLL, standardization. FLL it's like a voluntary assembly of all kinds of, it's an industry assembly of all kinds of measuring sticks, so that we can kind of compare product A to product B.
For the green roof specifically.
Yeah, for green roof specifically, and it is done mostly from a safety, from a construction perspective. It doesn't really give a damn about the plant or soil biology or natural systems. It's all about engineering. Yeah. So in a nutshell, so if I go to and my American client is the perfect audience for this. If I say, hey, you want to put up a green roof? It's good for bees and butterflies, and all these heat island effect and all these benefits and everything else. And they said, oh yeah, fantastic, we love it. Yes, sure, put it on. That's in the design phase. Then we get to construction, and then they go like, oh crap, guys, we're $500,000 short. You know, what do we have on the list that we don't necessarily need, that's just nice to have? And that's always the green roof. So it gets value engineered off because nobody in the room says, hey, you know what, this is a critical component of our building. It's done for PR, it's done for, whatever, a whole bunch of soft reasoning. And the Americans don't give a damn about any of that. It's the dollars and cents argument. So then we felt like, well, you know, so is there an ROI on the green roof? And if you're, you know, if you're looking at the roof as a piece of real estate that could generate a profit, then solar is one way to do that. Amenity space is one way to do that. And amenity space in the U.S. is it's like swimming pools, barbecues, gardens, you know. So you're
like a multifunctional roof, like using it for like some purpose.
Yeah. So that's a great investment, right? I mean, and they'll spend $1 million just literally, again, it's a 10-minute conversation to put $1 million green roof up there if it adds, you know, value to the real estate. It's just, and then they get to the extensive green roof, which is just basically a very, you know, policy-oriented stormwater tool. And then they say like, oh, you know what, if we don't have to, you know, it doesn't add any value. Yeah, as a matter of fact, it costs money to maintain the damn thing, so let's just take it off. And this happens so often, probably 90% of the time, you know, green gets removed from the roof. So the marketplace here in the U.S. is probably 0.00001% of black is actually converted to green, and it's mostly done in policy-oriented regions. Now, the exception of that is for instance, a Google and an Apple and the Gap Store, you know, and LL Bean. You know, they basically make so much money that they want to do the right thing by putting a little demo green roof up. But that's not really the marketplace. You know, that's like Rolls-Royce selling 3,000 vehicles worldwide. They'll never sell 1 million, but there's always an audience that has enough money to burn to buy a Rolls-Royce.
Yeah. It's not for the scaling up.
No. So what we want to be, you know, and if you look at, you know, pickup trucks and minivans, you know, that's the market that you want to be in, right? Toyotas, Hondas, you know, that's what we would like a green roof to be. Because now you're going to have a real impact worldwide.
Yeah.
So, and the way to do that is to confront that developer or building owner or architect and say, you know, where are you located in the city? Well, you know, I'm in an urban setting. It's okay, then space is one of your most critical, most valuable assets. Yes. If I can get you 2 more parking spots, how valuable is that to you? Parking spots. Wow, that's like gold, right? That's the language, the currency that everybody understands. And the moment you dangle that in front of somebody, you immediately have their interest. Yes, Oscar. As a matter of fact, we're short 6 spots. How can you do that? Like, well, not sure I can do it for sure, but you know, we can run a bunch of calculations. If you basically, so right now the civil engineer has 2 options, and I'm simplifying it a little bit, but he's got like 5 or 6, but the majority of the time they choose the following 2. They put the water that falls on top of your property, and it's the same pretty much in any Western world. All the water that falls on your property has to be temporarily stored on the property. You cannot release that at the peak moment. So that means you got to put the water somewhere. So let's say 5 centimeters of water falls on your property, and the complete property needs to be able to store that for a certain period of time. The release rate of the whole property, that includes the gardens, the parking lots, the building, everything else, the release rate of that property is set by the government or by the local city or by the province or whatever. And they'll say, hey, you can dump whatever 0.15 cubic meters per minute into the system. That's it. So then that's basically the throttle. That's the bottleneck. And then you design from the bottleneck. You design everything backwards. So then if you take a building, for example, the water falls on the roof. It goes down the gutter into either a tank or into a detention pond, which is, let's say, bioretention. Does that ring a bell? Bioretention? Yeah. So basically, it is some kind of a dry garden that can temporarily fill up with water, and then it cleanses. Yeah. So a tank is not really that popular because a tank doesn't clean and a tank doesn't reduce volume. A tank is just a pipeline with a fat bubble in the center. And the a bioretention pond or a green roof for that matter too, half the water basically can evaporate upwards. So it's a volume reduction tool, it's a detention tool, and it is a water quality tool. So that's great. But the civil would never put the water up on the green roof because the green roof doesn't work in the second day storm and in the XL storm. So now we have this purple roof concept, and the purple roof concept basically it is a mechanical tool. So we create friction in the drainage layer by putting it's a 5 millimeter machined product that has about 1,400 vertical threads that are standing upwards, and those threads create a certain turbulence and just resistance, and it doesn't allow the water to freely flow. And so the water will back up, and in all of the pore space, which is the larger cavities within the soil particles, we fill up all of that space, which is usually about an extra 20 or 30% in the soil profile, and then we can go above it, above the soil layer in the puddles of the soil. So we can temporarily, in case of a 4-inch roof, for instance, we can temporarily store about 2.5 inches of water. So that is, let's say, 6 centimeters of water we can temporarily store for about maybe 15 minutes, 20 minutes, maybe an hour, depending on the configuration of the roof. Let me take care of this little guy for 1 second. I'll be right back.
Yeah, no problem.
Yeah, no, sorry, I'm listening on the background, Alan. So no, just because I think Oscar is obviously very going into detail in terms of the water capacity that we can hold, and how we can obviously make this interesting from a client perspective, right? Because what our incentive is to basically show an ROI to the owner and make sure that we have the civils on board. I see Oscar is back, so please continue, Oscar.
Yeah, exactly. It's really about finding the business proposition that will go beyond the rose worlds and really make it kind of an essential part of the building design.
Correct. Yeah. If it is part of the infrastructure, then it cannot be value engineered. It cannot be removed. It has to be maintained, and there's not a single. A parking spot generates $10,000 a year in the city, in the U.S. city. In New York City, it's a hell of a lot more. It's like 30 grand. So it is absolutely just stunning if you multiply it over 40 years that a green roof could easily pay for itself. If you look at parking value, or maybe the building can, the lot is a little bit too small, but now by the removal of this bioretention pond, we can put another Starbucks, on the property, and that real estate is worth almost $1 million. So
let me just understand it. So what are you replacing? So I understand that you want to move the water retention to the roof, and then but where was this water retention before? Do you mean it was kind of in the basement, or was it in the garden?
It was either in a tank or in the garden.
Okay.
And if they put it in the basement and they're not parking cars in the basement, or they don't have an alternative purpose for that space in the basement, or maybe there's a rock in the basement and it's very difficult, for instance, or there's a very high water table. There might be all kinds of reasons why a tank is not either allowed or it's not doable. But in a tank can also be in the parking lot, for instance, and then of course the garden would allow the bioretention. So usually there are two choices: it's either a tank or it is a bioretention. But the third option, the green roof, is just basically never applied in the previous cases because of second day storm and XL storms. And now we're allowing that water to actually stay on the roof and come off the roof maybe 20 minutes or an hour later. And at that particular moment, a storage tank, or a bioretention pond, it is not a finite. So the definition of detention is that all the water will leave the system. So a tank has basically 10 gallons in and 1 gallon out, per minute. 10 gallons per minute in, 1 gallon a minute out. So it's a temporary balloon, but 24 hours later the tank is empty again. And the same thing with the detention pond. It has some retentive qualities, but the majority of the functionality is in the temporarily ballooning the water and then slowly releasing it again. So if you do that with a green roof, in some situations when we calculated this, actually a third party calculated this, we were able to completely eliminate the tank or bioretention. So in that case, they found themselves about 1,200 square feet of extra space, which in that case meant several automobiles that could be parked, and that was extremely valuable to the owner. So off they go.
And but would it mean in terms of kind of greening that they would perhaps take away greening in the garden and replace it with greening on the roof?
Well, it is also entirely possible, of course, that they would eliminate some garden space with, let's say that's the worst case scenario, right? They remove some garden space, but asphalt there and park 3 more cars. I guess that's funny. You're the first one to mention that one. That is a possibility, but the purple roof solution is basically a solution that's probably going to fit 20 to 30% of opportunities, because every situation is a little bit different. There's pros and cons to evaluate on every project, and we think it's important to have an arsenal of solutions, not just purple, because it is every project, the architecture, the location, the weather, everything is different, and you need to be, you need to understand stormwater management in order to figure out and evaluate what's best for the client. So blue-green, for instance, is something else that we are adding to the proposition. Blue-green is just a green roof sandwich, 4 inches, but then raised on a plastic structure of some sort. So we create an artificial cavity underneath, and that allows us to store an enormous amount of water, even way above and beyond 6 centimeters. You see them in Holland also quite regularly. So it's not to say, and we're not asking your help, let's say, to become an advocate for purple, but we are interested in seeing how you can add value, how we can go from black to green.
Yeah, no, definitely, yeah. And I know. So what I really appreciate in what you're sharing is that this realization that the real scaling up will happen when people see that it's gonna somehow give them a return or save them like real monetary costs, I guess, right? So that's
yeah, and then also the performance, because the German green roofs that are 4 centimeters thick, built with ping pong balls, and they're not vegetated at all because the crappers didn't want to grow. That is just not a stormwater tool.
Yeah.
So you're gonna get much more bang for your buck. The green roofs that you do have actually will do very specifically. A city planner can use it to calibrate. Because they all do. They all have, let's say, have a mechanical function, with a huge impact. So you're going to move from black to green, which makes the market literally 1,000 times larger.
Yeah.
And when you are already green, regardless because of policy and everything else, you're going to make it a higher quality product. So the impact of the square foot will be a lot higher. Yeah. Eva, why don't you take over for a second again? I got.
No, I can hear it.
Yeah. No, because Helen, I think we got an hour. We don't want to take more of your time than strictly necessary. Maybe. Oscar explained a lot, obviously, about what we're trying to achieve, or what we're actually working on. I don't think he mentioned, but we assembled a team, an in-house civil engineering team, and you refer to Joshua, but we have people working full-time, dedicated at our office in Culpeper, Virginia, which is actually not too far from where Oscar lives. It's half an hour from DC. But maybe you could let us know how we can help you and what specific questions you have, because quite frankly, we can talk another 2 hours about this. And again, we're working tirelessly on getting our objectives straight, and we're rolling it out to go to market. Really soon we have onboarded some partners, exclusively, one in the US, one in Singapore for Southeast Asia. We have a tremendous problem. South America we're looking into. In Europe we have 2 partners, so of which one is Knauf. Knauf is a big, I'm sure you know them, and we do a lot of work with them. So And this is, we are very confident that this is going to give a big push to the market. So please shoot and let us know how we can help you and what questions you have. And obviously, we're very excited about people that work in the industry like you, that that also have an interest in bringing this to the next level.
Yeah. I mean, I guess I don't work in the industry, but I do study the industry very much from the perspective of wanting to scale it up, and also very much from the perspective of how private actors can help scale it up, such as yourself. So you are an intermediary that can improve the value proposition of green in the city by also looking very closely at what the demands would be for your potential clients, right? To take this up. So you've done you have very good insights into these civil engineers who then decide whether to take a green roof or not.
And then there's another dimension. It is, it is kind of silly that our industry creates a standard profile and they apply that all across the U.S. In all these different climates, with the same soil and the same bucket and the same everything, and it's completely senseless. It's a waste of money in some areas, and it's not enough money in the other areas. So, the ET rate, if you think of the green roof is a bucket of water that is full January 1st because of frost and rain and everything else, then the bucket will only empty out because of ET. And so the amount of water you can put back in the bucket can never be more than the amount of ET that takes place during a year. So if you have a meter's worth of rainfall and you only have 30 centimeters worth of ET, it makes no sense to create a green roof that is bigger than 30 centimeters. And that's on an annual basis. I'm simplifying it a little bit. But on the other hand, you need to understand the individual rain events. So sometimes you have to create overcapacity. So the combination of understanding ET and then the individual weather patterns, which vary tremendously from Frankfurt to Amsterdam, for instance, it doesn't take a lot of money, actually. It just takes a full understanding of the opportunity. And then you can make a green roof 5 to 10 times more productive.
Yeah.
And right now they use a big brush and they just paint everything the same color.
Yeah, I mean, I think it's because I study other types of innovation, I recognize the pattern from, innovation in industries where in the beginning things are not perfect yet. So there's still a lot of product development. And I think you're one of the players that's doing this product development to make the value of the green roof higher and also to improve the communication and therefore also the trust in this tool. And then and then what you would want is that at some point there's this culture among civil engineers that they logically will put a green roof onto their houses because it makes sense and now they understand it. And innovations like what you are doing fit well to their purpose. So I see this as kind of a step in a journey that you're part of. And then the question would be for me is so one of the things I'm trying to do is to really kind of identify all the different business models for urban green. And I think so one of the models that I now call risk reduction, I think this is very much what you're talking about. So you're lowering the chance of having extreme costs, or at least this is where you're trying to deliver the civil engineers, right?
Yeah, it's basically we're creating space. I guess we're managing water on the roof where it hasn't been managed before.
Yeah. So exactly. So it's a combination. So you're playing with the current investment that a building property is doing for the water retention to reduce the risk of flooding, but you're moving this space to the roof. So you're playing with the fact that there are dense areas where square meters are very valuable. So you can use the roof, which is now not being used, and instead, make new parking space or other or give it other uses. So I think that's
Yeah, and also, if you're in a market like Munich, where you have to do a green roof mandatorily anyways, let's just make the thing actually functional and let's make it work.
Yeah, make it give you something. And I mean, the argument that I haven't heard you use yet, which I see a lot here in the Netherlands, is that your roof actually lasts twice as long if you put a green roof on top.
No.
Is it true, or is it not?
No, that is self-fulfilling. No, we ran the whole calculations, and I would never ever do a green roof to double the life of my membrane. It's a lot cheaper to put a new roof on there. It's
cheaper to put a new roof than to.
Yeah, that might be, that's a little different in the Netherlands, because over there they, a green roof is a lower price point, let's say $5 to $7 a square foot. And then over here in the US, it's like, say, $15 a square foot. So the numbers might be a little bit different in Europe, but also roofing is a lot cheaper in Europe than it is over here. So, but a roof membrane, for $4 or $5, you get a brand new roof, a square foot. And, it's just, a green roof you have to maintain for a number of years. Do I think green roofs are great? Yeah, absolutely, obviously. And even if the costs were the same, we've taken an enormous amount of garbage out of the waste stream, because, all things being equal, if both things cost $12 after 20 years, let's say, then we only had to dump one roof into the waste stream. Roof insulation is about 20 centimeters per square meter. So think of an Albert Heijn that has to replace its roof. It is an insane amount of foam that goes into the landfill. And by that times billions of square feet that are being done every year. That is insane how much.
So it's not from a cost perspective, but when you are looking to be, for example, a circular building, or you have regulation on the amount of waste you can produce from a building, then that would be another interesting value proposition to add. So then, because in the Netherlands, actually a lot of there's quite a lot of attention around circular buildings. So in that sense, that could be a value proposition as well.
But what we need to do as an industry, we need to stop using arguments that are plain bullshit and that are just, let's say, not factual. Because when people say that, put a green roof on, you double the life of the membrane, they don't take into consideration how much money it costs to take the green roof off the building so that you can re-roof it and then put it back on the building again. They don't think about that. So if you truly do the math, so let's say a building owner that's done his homework, or a civil engineer that's done his homework, or they get turned off by these lame arguments that we use as an industry, that just don't hold water, literally.
Okay. No, well, I've been working with the Green Deal Green Roofs. You might be aware of them, but they're like a stakeholder network in the Netherlands that aim to upscale green roofs in the Netherlands. And they made this facts and value sheet. So they used a lot of literature to create this on all the different benefits that green roofs deliver. They translated it to English as well. And the roof longevity is one of them. I mean, there's a lot different values on there. But what I am starting to understand from the green roof sector is that I think the stormwater management, the water retention is one of the main reasons for actors to engage in it, both from a municipality perspective. The subsidies often come from a water management objective. We now see a couple of insurance firms interested in it. I think there's an interesting participant that could, have an incentive to upscale green roofs as well from a stormwater retention perspective. In terms of perhaps if they give insurance, how do you say that, a polish, if they sell an insurance product and you have a green roof on your building, perhaps you can have a lower fee because you are keeping the water on your parcel. But that's another thing which I'm not sure about the US and all different places where you say, well, you're obliged to keep the water on your parcel for a certain amount of time. I wonder how this differs between countries actually. I'm not sure if this is always the case in the Netherlands, for example. So whether these facilities are already there.
Hey, Sarah, do you mind? Sorry.
Yeah, maybe we should stop.
I'm going to have a little boy here in the background, and he is.
No, I understand. You know, we can stop it here.
Ivo, would you mind discussing a little bit about the interaction between the two parties and see what potentially is meaningful?
Sure. Yeah, no, I'll continue with Helen and also see if we can be of any help, obviously with her research or maybe supporting her students in whatever way possible. I'll take it from you, Oscar. Appreciate it.
Hey, thank you, Helen, for your time.
Thank you for your time as well. It's really nice to meet you, and thanks so much for your detailed explanation. It gives me a lot of food for thought. So I'll discuss with Ivo then about how we can maybe take this further, or how what else. And good luck with this whole endeavor. I mean, it sounds like it's really a really good adventure.
Yeah, it's super exciting. I wouldn't know what else we would do if we didn't have a good ROI argument, because it's it's not growing fast enough the way it is. But thank you very much. I think there's a great opportunity there. Ivo, apologies.
No worries.
Noise over there. I'm gonna have to deal with that right now.
Yeah. I won't take either. Thank you. Thank you.
Yeah.
Yeah, no. Sorry, Hal, about that, but it's I think.
It's totally fine. I mean, I could also go home to my kids now, so I mean, maybe 5 more minutes, and then
Sure.
I'll probably also have to wrap up. But yeah, no, it's really nice to get a kind of an idea of, you know, also the thoughts and also the challenges that you're into, and also the choice of, you know, really selling it on ROE is, I think.
Right.
I think it's a good decision. I'm also realizing you're not fully positive about, you know, regulation as a way to stimulate this, whereas I've spoken to other people who say, well, you know, regulation can improve the ROE in a certain way, like it can improve the business case, because we have to do drainage, and then, you know, it becomes more of an opportunity cost.
But we basically approach it from a different angle, because politics takes forever. We can start lobbying, and in the US, you know, corporates are very strong in that regard. But changing current regulations will take us 5 to 8 years, and we don't have that time. So if we want to act, we ask for exceptions from civil engineers. We talk to regulators in Chicago, in New York. We have those conversations, ongoing conversations, to get exceptions, for our projects. And the reality is also, when we start with green roofs, green walls, all of it is the moment we have some reference projects, people are familiar, people have the trust, as you mentioned. We have hard data, because obviously we have an in-house civil engineering firm. This all has to be verified by an external consultant as well. Once these numbers are set in stone, are confirmed, people feel familiar, people feel comfortable. It's going to be a more copy-paste exercise. So this is one thing I wanted to emphasize. Second thing, I think Oscar didn't mention. So we're building the school with our in-house civil engineering team, where basically we can, based on historical climate data, we can incorporate the ideal green roof recipe, or purple roof, as you know, whatever the sandwich, as Oscar referred to, and basically determine what the ideal assembly would be for Chicago or New York or Atlanta or whatever. So if you look at the website purpleroof.com, purpleroof.com, you will see that we're working on this modular, hydrologic modular, which is almost finalized, but obviously it's a lot of work, and we did a lot of testing, and then we really have the tools to determine, you know, how much water we can retain, detain, and as Oscar mentioned, obviously a purple roof assembly doesn't make sense for a lot of projects. Obviously, if it's in the rural countryside, it doesn't make sense, because space is very cheap. You can just have the water next door. But in urbanized environments like Manhattan, downtown Chicago, Boston, and so on, where space is very expensive, where they have to, in Manhattan, all these water tanks are below structure, so they have to dig concrete, very expensive. And so if we can show that, again, that they can build a Starbucks, 4 parking spots, 20 grand a year. We start running the numbers, and now we can offset 50% of the green move investment, for example. And I think that will really start opening some eyes. We have some very big developers here in the U.S. that I visit, that we have on board. In Boston is one of the biggest developers in the U.S. They visited our office, and they're very much amazed by how seriously we take this, and they're very interested also to implement this in their property. So I think it's really something that we have been working on for 2-3 years, and quite frankly, Oscar didn't mention, but we were working on the green move in Mexico. You should Google it if you haven't seen the project, but it's the biggest green move in the Americas, Mexico City Airport. And you can Google the rendering. It's a beautiful green move. It's 8 soccer fields, so it's huge. Oscar and I were working on that for the last 3 years until the newly elected president, Mr. AMLO, a populist president, promised during his campaign that he would cancel the airport project. And so the reality is that they already poured all the concrete. They engineered everything. They already spent $4 billion out of a budget of $13 billion, and now it's on hold. So we were almost there to sign the contract to get the green move. But the good thing is that this was basically the reason why we started with this in the first place, because of Mexico, the climate, Mexico City, the moon climate, quite frankly. So you have, Oscar Partners was the architect, and they basically designed the green move out of London. They copy-pasted it for Mexico, and obviously, as we mentioned, that doesn't work. And especially in the monsoon climate, you have just plants swimming in a swimming pool for 4 months of the year, just because it's soaking wet, and 4 months of the year it's bone dry. So that's how this exercise started, and that we needed to find a green move that works. So that is a little bit the background. That's also a little bit, in terms of this modular that we're building, this tool for everybody to work with. And as Oscar mentioned, civils are really the driver of our business. If we get them on board, if they see, if it makes sense for them to incorporate a green move, and they do understand it, we do think that we have a very strong value proposition to bring green moves to a more, how do I say, and if we could capture 1% would be great, but at least to really give it a big boost. Although, as Oscar said, now it's just it's a commodity, and there is no value, and we're going to sell value. So that's a little bit the background, Helen. I really appreciate it. To have this call, explain a little bit what we do.
Yeah.
I think I would like to know if you have more questions. Obviously, we will be more than happy to schedule another call in the near future. You can also send an email. We're always happy to explain what we do, how we do it. If we can help you in any way possible, or your students, feel free to let us know.
Yeah, I mean, one thing I'm thinking about is we have one student, a finance student, and his family has a roofing firm in Hungary, actually, which is quite funny.
Oh, wow.
But he's currently trying to build for his thesis a valuation model for green roofs, which is quite a challenge. But I can imagine that it might be interesting for him at some point to either present some of his thoughts to you, or even ask you a bit about your ROI model.
Sure.
Because it is his approach as well.
Sure.
I'm sure it's going to be, it's not going to be a model for the whole world. It'll be, something which is a master thesis.
Sure.
With all kinds of restrictions, but still, I mean, I think it's an interesting topic.
Sure. We're very happy to help. So at least refer or send them our way, or however you want to do the communication. But we're happy to accommodate.
Yeah. And I mean, the other thing is, so now I'm doing all this research, and then we will be, doing our analysis at the end of the year, and then somewhere in the coming, in like especially towards the end of the year, 2020, we'll be doing more kind of valorization. Explaining firms how they can make business models around nature. So I can imagine that perhaps you could figure as an example there at some point, either from the information that I have now from the interview, or even, with some nice pictures, or so I mean, I have to think about how to do this exactly, but those are my first thoughts.
Sure. Yeah, no, I think, I saw your profile, again, we have quite an extensive network, and I thought, it would be good fit just to see a little bit what you do, how you do it, and I'm sure, we have a lot of people that we are working with or communicating with, in our network. So, also in terms of, if we can help you with anything or connections or, whatever, just let us know. I think it's always good to have people from the regulatory side, from the industry side, from the academic side, communication channels to see what everybody's working on and how we can bring this all together because we have the same objective.
No, I mean, really, thanks a lot for getting in touch. It's been really nice to hear about it.
Yeah, no. So we live the American dream, as I say. So we took the boat. And really trying to push the green infrastructure industry here, and quite frankly, as Dutch people, right? Because we all have the Dutch background, all born and raised, and we are taking very seriously here in the U.S. Quite frankly, as you know, they're not just the biggest exporter of plants in the world, and quite frankly, that is our main business, plants. But here in the U.S., it's just people. If we don't do anything in 20 years, it's still going to be all the same. So we really need to drive the market. We have a lot of support from the Dutch embassy as well, and I think really cool things are going to happen. So I appreciate the time again. I will make sure that Oscar and I will sign off. You will have that tomorrow morning Dutch time in your email box. Don't worry about it.
Thanks a lot.
Please keep us posted how we can help. I really appreciate the time.
Yeah, really nice. Thanks so much. And good luck on your really good work.
Yeah, no, thank you. I appreciate it. No, we're really trying to push really hard. So I appreciate it. If you ever happen to be around in the U.S., New York, or D.C., let us know, or Chicago, because it would be great if you could visit. Our cash lab and everything.
I try not to fly too much because of carbon emissions, but if I would be there, then sure,
If you happen to be around. Open invitation. Perfect.
Yeah, great. Thanks so much.
Thank you for your time.
Enjoy your day. Bye-bye.
Bye-bye.